Algebra students, this is Mr. Kashi speaking. With this video, we're going to be going through 10-2 Day 2, which is Arithmetic Series. The video before this, we were talking about arithmetic sequences, which is very important because you're not going to be able to find the series unless you know what the sequence is. Just what a series is the indicated sum of the terms of an arithmetic sequence. So if you take the first, second, and third terms, and just add up all of the terms. Something as simple as like if you wanted to find the sum of 3 of just let's just say we have 1, 3, 5. All you would be doing, S of 3 would be 1 plus 3 plus 5. To add up those three terms, that would be 9. So nothing. Just adding up the terms of the sequence and coming up with an actual number of what those are all added to. So I do want to go through and kind of talk about what each of these variables mean in these formulas. So this n right here, up there, that is the term number of the last term that we're talking about, that we're referencing there. I think you remember this. This a of 1, that's just our first term. And a of n, that's going to be our last term. So if we wanted to find like the fifth term or the 20th term or the 100th term, it's going to be our last one. So just to review our arithmetic sequence formula, because we are going to be using this, so I'll just kind of stay with the same numbers as we had for the sum over here. So that would be the term number of the last term. I just want to make this look similar to what we just did with our oh, sorry, this was kind of a copy. It should be series. And then A1 right there, that would be our first term. I went over this in my last video, but it is important that we know what all these are. And then this is going to be common difference. And then hopefully you can see how the last term, that's what we're actually finding. We're going to have to use the arithmetic sequence formula to find our last term so we can then plug it in to our series formula. So we're going to go over an example here. And really, one thing that I've always done is we're going to just list out the things that we need for our sum. So we have a of 1, instead of a of n, or it's going to be a of 12, and then we need to know what n is. And actually, we know two of these. We know that our first term is 1 from our list right there, and n is going to be 12. We know that, but we don't know what our 12th term is. Unless you want to count out how many, and in this case you probably could. It's not that much. You're just adding 4 each time to get out to the 12th term. But if this was the 100th term or the 1000th term, you wouldn't want to just count out to find out what that is. So that's what we're going to have to do first. So the first thing we need to do is find A12. And that's where we're going to use this formula up here. Our first term, A1, would be 1, plus, this would be 12 minus 1, times our common difference. Well, we keep going up by 4, so that's going to be times 4. So this is just to simplify, 1 plus 11 times 4. So 44 plus 1, this should be 45, so 45 should go here. And then what you can do is, now that we have all those three things, now we can find our S of 12. So I'll go over here. We have S of 12 equals, we have n divided by 2. So this is 12 divided by 2. Then our first term of 1 plus our last term of 45. So this is, this really turns into just some arithmetic. So here we'd have 6 times 46. And this is obviously something that you can use a calculator on. 6 times 46, your sum of the 12 terms would end up being 276. And you could give you could plug this into a lot of these into your calculators and a lot sooner. I just like to kind of simplify here a little bit. So moving on to our next example, and we're going to do those same things. So here we have S of 40, and they give us the first 4 terms. So we need A of 1, we need A of 40, we need our 40th term, and we need our N. Well, our first term is -3, as you can see from our sequence there. And our N is 40, but we do need to find our 40th term. So we have to use that arithmetic sequence formula. So A of 40 equals our first term, -3, plus 40 minus 1 times our common difference. Well, we keep going up here by 7, so our common difference would be 7. So A of 40 equals -3 plus 39 times 7. So you can plug that into your calculator and come out with 272. And all that tells us is our last term. That is our 40th term that we're going to be using. So now that we have those 3 things, we can go find the sum of those 40 terms. So we need 40 divided by 2, n divided by 2. We're talking about the 40 terms. Our first term is -3. Our last term is 272. So this would turn into 20 times. That would be 269. And when you multiply that out, you find out that that sum becomes 5,380. And I know especially with these videos, we're just getting into the nuts and bolts and the arithmetic thing, but really, hopefully you can see how you could start using this for finance. If you were to increase your payment into a savings account by this much each day, how much money would you have at the end of the 40 days, or how this can start applying to your real life. But we'll move on to a couple more examples here. So once again, we have S of 25. So we need A of 1, A of 25, and we need our N. So A of 1, we have 28 as our first term from our list of numbers right there. Our N is 25, and then our A of 25, we need to find our last term again. So we have A of 25 equals our first term, 28, plus 25 minus 1 times our common difference. Well, now we're going down, so this would be adding a -4 each time. So this would be a -4 for our common difference. So A of 25 equals 28 plus 24 times -4. Remember, that's a -4. That's going to be important. You can't use +4 there. You can plug that into your calculator. Once you get there, you find that that is -68, and that is our 25th term, all the way down to -68. So now, I know our last one got to be a pretty large number, but if you can think about it, we're starting in the positives, but then we're going to cross over 0 and go negative. We're going to go all the way down to -68, and then we're going to add all those up. So we have more negative numbers than positive numbers, because we go down all the way down to -68, but we only start at +28. And so our answer is going to be negative. Hopefully you can kind of conceptualize that before we even calculate that. So here we have n divided by 2, so 25 divided by 2. Then our first term of 28, add our last term of -68, like that. So S of 25 equals, this would actually be 12.5 times, this would end up being -40. And when you multiply that, your sum ends up being a -500. So I know it seems a little crazy that we're getting decimals when we're actually using whole numbers, but when we multiply it out, we using the formula, obviously you would get a whole number of negative 500 as your complete sum. So I want to switch gears for this last one a little bit, and it looks more confusing, but actually it's going to save you work when we have things in this notation. So we're going to kind of go through the same process, but hopefully you remember our video on sigma notation. All this means is that we're going to add things up. Our n equals 1, that's our first term, 20, that's our last term, okay? So, but here, it's not telling us what those terms are. We have to use this explicit formula to find those terms. So, we still need to find a of 1, we still need to find a of 20, and our n, well, that's the one thing that we do know, our n is 20. That's how many terms that we're going to be using here. So now a of 1, what we have to do is we have to go 3 plus 2 times 1. We actually have to plug that 1 in for n, and that's going to equal 6. And then to find the 20th term, we have to plug in 20. So 2 times 20, that's 40, plus 3, this is 43. So we didn't have to use the formula as much this time, but we just used the explicit formula inside our sigma notation there. So then we can switch over and do the sum right away. So the sum of 20 that we wanted to find would be 20 divided by 2, that's our n divided by 2, times our first term of 6, plus our last term of 43. So this would, obviously, 20 divided by 2, that would give us a 10, and 6 plus 43, this would give us 49. This is one that hopefully you can do in your head, 10 times 49. Our sum here would be 490. So these are a handful of problems that I hope helped just going through these arithmetic series, taking a series of numbers, adding them up, and obviously trusting the formula, being able to find those terms using the arithmetic sequence formula as well is obviously going to be necessary to do this. So I believe your assignment today is on quizzes instead of ALEKS, but hopefully these examples helped, and let me know if you need any help.